The next subtraction strategy we're going to talk about is called constant difference. We're going to start with some cubes and make sense of what constant difference means before we practice actually doing some subtraction problems with it. So here I have a set of cubes, and I'm modeling the difference between 5 and 3. So if we think about 5 minus 3, to find the difference is represented right here by my cubes. The difference between these two sticks of cubes, 5 and 3, is 2 cubes. See it right there? What happens to the difference if I add 1 cube to each stick? So now I have 6 and 4. And what is the difference between 6 and 4? It's still 2. What if I add 2 cubes onto each of these sticks? So I'm going to add 1 to my top one and 1 to my bottom one. Now I have 7 and 5. What is the difference between 7 and 5? Still 2. All right, what if we go back to our original 5 minus 3, and this time, instead of adding to both of our sticks, we're going to take away from both our sticks. So I'm going to take 1 off of each stick. So instead of having 5 minus 3, now I have 4 minus 2. And the difference is still 2. This is why the strategy we're about to practice, called constant difference, works. The idea is that when I have 2 quantities and I want to find the difference between them, if I add on the same amount to both quantities, or if I take off the same amount from both quantities, the difference stays the same. It's a constant difference. Now, some people call this constant distance, and I'm going to show you why. Let's look at a number line. I have 3 and 5, and I want to find the distance between these 2 points. If I add 1 to both numbers, I move this way and this way, the distance between my 2 new points is the same as the distance between my original points, because they both moved the same amount on the number line. A good example for this is ages. I have 2 kids. They are 2 years apart in age. So right now one of them is 19 and one of them is 17. 5 years ago, how far apart were their ages? 2 years, because they both were 5 years younger. 3 years in the future, how far apart will their ages be? 2 years, because they both get 3 years older. Every time one gets a year older, the other one gets a year older, so the ages are the same distance apart all the time. So let's apply this to some subtraction problems. Let's think about 24 minus 19. If I'm trying to subtract or find the difference between 24 and 19, I can make a friendly number by adding 1 to the 19 to make it 20, which means I also need to add 1 to the 24 and make it 25. When I do this, the distance between these has not changed. Let's just label these. "25 minus 20 is equal to 5. And we could also count in this one, 24 minus 19 was also 5. So this one's pretty easy to count. It's probably not a more efficient way to solve this problem, but let's look at some where it might be. Okay, 336 minus 197. I could subtract this using the standard algorithm. This is another one of those problems where I would have to regroup or rename multiple times. Or I can think about constant difference, and I have 336 and 197, and I'm trying to find the difference between the two. 197 is pretty close to a friendly number. If I add 3, I can get that to be 200. So let's add 3 to 336 also. So when I start with 336 minus 197, and I add 3 to the top and the bottom number, I will get 339 minus 200. And I no longer have to regroup at all. Now I have 139. You can see if I did all of the regrouping and renaming, I'm going to end up with 16 ones minus 7 ones is 9 ones, 12 tens minus 9 tens is 3 tens, and 2 hundreds minus 100 is 100. So we get the same difference, but here we took a lot less steps. Let's try one more. This time we have 400 minus 168. We are trying to find the difference between 400 and 168. This is going to require, because of all these zeros, a lot of renaming and regrouping. So let's think about what strategy we could use that would help us. Adding a number here isn't super helpful because we'd have to add a lot. But what if I subtract 1? 1 less than 400 is 399, and that saves me from all my regrouping. So let's change the way we're labeling our boxes here. And let's take 1 off of each of these. The other part of 400 would be 399. The other part of 168 would be 167. So let's think about this subtraction. If I had 400 minus 168 and I subtract 1 from each, now I end up with 399 minus 167, and I don't have to do any renaming. I can just go ahead and do my subtraction. So real quickly, before we finish out this video, pretend you're a 4th grade teacher for a moment and your students need to solve this problem. This strategy might not have seemed super powerful with a 2-digit number, but when you know at this point that you could just subtract 1 from each of these and end up with this problem instead, this feels like a very powerful subtraction strategy.